last year. So yeah, it's going to be Rust to build a web application, and more specifically the front end part of this application, and using WebAssembly to make that work in the browser. So yeah, let's start. Why can I change slides? Okay, there you go. So as we all know, it's much more interesting to work on the the back end than the front end, of course. And one of the reasons for that is like you're limited to JavaScript when working on the front end. And JavaScript is nice, but it has its flaws. For example, the typing system, I don't really like it. Yeah, and other reasons as well. So yeah, why don't we use backend languages for front-end application then? Actually, now we kind of can. So with WebAssembly, so what is WebAssembly? So we write some language in a backend programming language. I'm going to use Rust, but we can use C, C++, Go, and some other languages as well. Then we compile that into some bytecode, and then we have a lightweight interpreter like compiler and interpreter that runs inside the browser and that displays that to the user. If you want to know more about that, I put some links in almost every slide. I put links. I send the slides at the end of the talk. The goals of WebAssembly is basically to allow people, there are two things, allow people to use other languages than JavaScript in the browser, and to have applications that run very fast at native or almost native performance. That's something that JavaScript cannot really do. So they kind of go together. So the languages that we can use for that, the best one is Rust. The reason for that is that Rust was created by Mozilla and is maintained mostly by Mozilla. And it's the same thing for WebAssembly. So they make a lot of effort to make them work together. So it's probably the language that has the most advanced ecosystem around WebAssembly. But you can also use, as I said, Go and some other languages. So some of the use case we can see, I'm going to start with the right-hand side of the screen here. There are actually some applications already using that. So Google Earth, probably everyone knows that. And then AutoCAD, which is a very big 3D modelization software. So it needs a lot of resources, but they're actually making the version that runs in the browser. And that's probably like the most advanced application at this day that uses WebAssembly. But you can do anything like 3D games, or even your IDE. In the future, we might have IDEs that run in the browser and that have the same performance as something actually running on your machine. Use case number 2, writing the source code once and then deploying it to native applications, macOS, Windows, Linux, and also deploying the same code to the browser. So it goes hand in hand with running fat clients most of the time. And number 3, moving workloads from servers to clients. So yeah, we can use the client's processing capabilities to run some of the load to have smaller servers, basically. So one example project using WebAssembly is a Game Boy emulator running in the browser. So it's something that clearly is not easy to do in JavaScript, especially running fast. So yeah, here's the link. You can check it out. Yeah, I think it works. I didn't try it myself, but it works. So the way it's WASM is executed in the browser is pretty similar to JavaScript. So JavaScript, you download the file from a remote server, and then the JavaScript engine in your browser will parse it, compile it, and execute it. So in Google, for example, it's V8, that's the name of the JavaScript engine. And every major browser has their own JavaScript engine, apart from Microsoft Edge, which is also using V8. For WASM, it's actually the same thing. It's the same JavaScript engine, so it doesn't do JavaScript only anymore. They also, most of them in all the major browsers, they can also pass WASM. So it's, the process is pretty similar. You download the bytecode that was generated, and then you compile it to something that your browser can, to machine code that your browser can execute, and then you run it. So I won't go into too many details, first because I don't understand all the details of how that works, and second because that's probably like a 2 hours talk. But V8 is one of the best pieces of software that exists. And it's very interesting to look in what they've done. So when V8 tries to process WASM code, there are actually two compilers, not just one. So the first one is called liftoff. It will try to compile as fast as possible and start getting something in the screen. The second one is called turbofan, and it will process one function after the other. So it compiles function by function, and does a lot of optimization to make that run fast. In the example of AutoCAD that I talked about earlier, this takes about 30 seconds to compile. So for 30 seconds, if you just had turbofan, you would just wait and nothing would appear on the screen. So what they do, they try to display something as quickly as possible using liftoff. It might take like 1 or 2 seconds. And then function after function, you start replacing the machine code that was generated by something way more optimized. So V8, when it compiles JavaScripts, there are actually 3 steps, not just 2. So it's even more sophisticated. So yeah, for example, in that case, we have function ABC. Liftoff would compile all of them as quickly as possible, and then turbofan would optimize function A, and it will replace what was generated by liftoff in the machine code, and then do the same thing for B and then C. So more links you can check out later. And let's jump onto a project I built. So my project is a pathfinder algorithm visualization. So finding the shortest way from A to B and seeing that. So I used a very simple algorithm, not something that's actually effective, just for the sake of the demo. And yeah, just a 2D matrix. So let's switch to the code. I'll start with a very short introduction on how that works. So I built a very simple index file. That's what gets loaded by the browser. It references a file that we will generate later, and also a CSS sheet. So we have some nice colors and some nice animations. So as you can see, we have 4 files here. These files get generated by, you can use different tools, but tools that compile Rust into WASM. They take Rust code that's here in a single file, because I didn't know at the time how to split Rust code in several files. So there's just one massive file, and then takes the Rust code, puts it into JavaScript and WASM. The JavaScript is just for linking. So it will import some things, and basically it cannot run natively, I think, yet. So we need some JavaScript to load the modules and load some stuff and that kind of things. So then let's go in the code. I'll start with that. So I'm using a front-end framework. It's very inspired by React, and the goal is to make something quite similar in Rust. It's really not effective at the moment. I mean, it's the performance is terrible, and it doesn't do everything you want, and it's still a beta, but yeah, that's the best I could find. So yeah, we always start with that component. So that's pretty much an interface. That's the Golang equivalent would be an interface. It has it's more complex. A trait that's called a trait in Rust is more complex than an interface. But yeah, you could say that in Java that would be grid implements component, for example. So when you implement that, the structure building is a component, and it can be displayed in the browser. So you have some hooks you can call. So they're pretty much hard-coded. So if you call a function create, this function will be called when you try to instantiate the component. So in our case, oh, maybe I could show you the result first, and then we jump into the code. It will be more interactive. Let's run it. I already built it, so I'm just going to serve the code that was generated.
Yeah.
A little bit later.
So
you start the you put a starting point, then you put the point you want to reach, then you put some walls, and I put other walls in here, and then whenever you're ready, you press start, and it's going to try to reach the target. And then something cool you can do is once that's done, you can actually add walls, and it's going to recalculate the path. you can move things around and it's recalculating things. And I did the same thing in JavaScript, and it was very, 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 very slow. Like it loaded forever. So yeah, you can just move it super fast. It looks a bit laggy because of the CSS animation, but it's actually quite fast. And yeah, it just recalculates on the run. So yeah, you can just move things around, and yeah, looks great. So yeah, going back to the code. Let's see how it works. So first we just do some initialization. We have some stages. I call them stages. So you start with a stage init, where nothing happens, and then every time you do something, you go to the next stage. So the first stage, you have to place the starting node. Then second stage, you place the targets, and then you place the walls. And yeah, you can also remove them. We also create the matrix. So there's a width and the height. So it's actually, I use the JavaScript. So you can use the browser API. So if I make it smaller and then I press reset, it's just going to have fewer cells. So yeah, you can just use the JavaScript API, the console object, I think it's called, or the window object. Yeah, let's move back to the code one more time. Yeah, then we have hooks, just like in React. So update, that's something that's called when we send a message. That's the way we communicate. So every time I do something in there, it's going to send a message. When I click, it's going to send a message. That's something I define myself. So if I go to the definition, I find it. Where is it? Okay, it's there. So yeah, you can have several types of messages, but basically I have only a few. So next is something that's triggered every time you do something. You have reset, which is triggered when you click the reset button. Start is triggered when you click the start button, and so on. That's some mouse things. So I define them myself and then plug them down in the JavaScript API for mouse clicks, basically. So hover is when my mouse is hovering a cell. That's useful for placing the walls because I'm not releasing the mouse button. Same thing for down and up. They're also used for placing the walls mainly, and also to yeah, place the start targets and that kind of stuff and move the things around. So yeah, I'm going to go over the pattern matching really quickly. So as you saw, that's an enum. Message is an enum. So you have 6 different states. So that's so enums in Rust. They can have parameters or they can be empty. I don't know what the terminology is, but yeah, this one doesn't have any parameter. This one has 2 unsigned integers. So in that case, hover, that's X and Y in the grid. So in there, when I'm hovering this, it will send a message. Okay, at the moment, the mouse is hovering column 20 and row 5, for example. And then you can use enums in Rust using pattern matching. So it's quite similar to a switch you would have in other languages, but it actually forces you to implement all the possibilities of the enum. So we have 6 enum options. If I remove one of them, then the compiler is going to complain. So I have an error there saying, okay, pattern reset is not covered. So yeah, it's a switch basically you have to implement with everything. And the way the update works, you can do some changes to the state of the application, and then you return either true, that means do an update the HTML done, or false, don't do anything. So for example, if we're on the stage, so if we have the message next, that's only supposed to happen on the stage started. If it's happening on anything else, then you don't do anything, you don't update anything, just follow. So for example, if I'm there and I'm hovering doesn't do anything. So in that case, we'll just keep early. So we can see here, if self is down, so if I'm pressing the mouse button down, you do something when you're hovering, Otherwise, otherwise you just don't do anything. So basically it makes the code very easy to write. You don't have to make tons of ifs and elses and account for every single situation possible. You just have a message and then some state, and you do a different thing depending on the state. So I won't go.
Can I ask something?
Yeah.
While we're looking at this code, is there a difference between the a num value without like a function, or like for example the message up in 197 and
Yeah, no.
This one. Oh, okay, so there is no difference. Okay.
Let's see. No, it doesn't change. So it's very different to Go in the sense that in Rust you can do the same thing in maybe 50 different ways. Like there are so many ways of doing the exact same thing. So
okay.
the same. Yeah, what else? Then you have the view. I'm going to go over the view. That's yeah, just like React's JSX. You put some HTML in there, and you have it's a templating language. So you put HTML, and every time you open brackets, then you put Rust code in there. And to say to go back to HTML, you use this. It's called a Rust macro. Basically, if you have that before the thing, you have to write HTML in there, and it's going to generate HTML code for you. And if you just put brackets, you put Rust code. So you can see I'm going back and forth. So I'm doing HTML, and then Rust, and then HTML again, and then Rust again. Right? So you can just interpolate whatever you want. You're supposed to split things in components in front-end applications. Yeah, I didn't do it. I just put almost everything in one component. I think I have 2 components in the whole thing. So it's not what you're supposed to do. They're supposed to be much simpler than that. Yeah, that's the part I didn't really make work with components. So that's how you build the matrix. You go over all the rows of the matrix, and then for each row, you go over each column. And every time you have a cell, that's a space, basically, a space that the browser has to display. So yeah, what else can we see? So for example, so we have a state of the application. The state gets updated as we've seen on the update hook. So every time an event happens, it can modify the state. And this displays the current state. So this gets updated every time we return true in the update hook. So for example, for displaying the right color, we display a cell, and then we go to that function. And again, we have an enum with what the cell should be. So it can be empty. That's the color you've seen here. It can be the start node, it can be the target node, it can be a wall, and it can be, I think it's called visited, this one, and the yellow one is path. So if I go back to there, you can see that's all the possible states. And then we're just going to make a match again. So we match the pattern, and we say, okay, if it's path, then you use this CSS class and pop, which is the animation. So if you can see the walls to target the start node and the path pop when you change something, there's a little animation just because it gets added there, because the state of the cell gets changed. But for things like empty, when you go to empty, it doesn't pop because it would look weird. So you don't include that here. Here I've done so that could be a pattern matching in here. That's doing exactly the same job as this, but a bit differently. Basically, this is the same syntax as this, but using an if and an else. So yeah, I can rewrite this, for example. So if I do match stage, in the case where it's stage started, I'm going to return a string, let's say solving. And then in every other case, I'm going to return that. And that's exactly the same code. So yeah, you can see Rust, they're changing the API quite a bit, and some things have advantages that the others don't. So in this case, for example, I feel like this is much more readable than this one. So you can keep this. So basically, you solve different problems with different ways of writing the code. Same for strings. You have like 20 different ways of representing strings, and I don't understand what's the difference between any of them. So yeah, Rust can be a bit confusing sometimes. It gives you lots and lots and lots of options, and you just do whatever you want. Yeah, I think I went over most of the things. So I'm just going to finish my slides, and then we can go back maybe for a bit more code or how to get started writing that. Where is it? In there. So yeah, how do we compile that? I said we had several options. Basically, we use something. I use something that's kind of like Webpack, but you have different options you can use. So if you're building a very performance-intensive application, you might want to use something else that's called Wasm Bindgen. And basically, that gives you tons and tons and tons of configuration options where you can really optimize Wasm to do what you really want. But for something very simple like this application I just showed you that has everything in one file, then you just use the standard thing and just build everything into one JS file. So what I want to say with this slide is that it's still a very, it's not really mature. There are lots of options to do the same thing, and there isn't really any consensus, and every tool is still being built. I think, yeah, the next slide says exactly that. So the framework I used on the front for the front-end applications called Vue. It's a very beta, in a beta state. Wasm is already getting better, but it's still not used by a lot of production applications. And compiling Rust into Wasm isn't really production ready either. So yeah, in a few more years, maybe it will be used everywhere. But at the moment, it's not really something we want to consider because there will be a lot of headache involved if we do anything with that. And also the performance is of this specific tool I'm using, specific framework is quite bad. But something to note is that actually compiling Rust to Wasm is already faster than native JavaScript. So if you have a need and you want something to be very fast, you might want to use that already. And it will always, I mean, it will only get better with time. So JavaScript is very, very, very optimized, and Wasm is pretty much the opposite. So it's going to, the difference is going to get bigger and bigger. And yeah, I'm going yeah, just I'll send the slides. So if you want to try it by yourself, I made a starter repo where you have pretty much everything you need to start. You just press, just type make run, and it's going to run everything for you. So you can just make modifications. And also, if you want to work on that project, like just to try it out and see what you can do, there are a couple of things that can be done. So, for example, I'm using a very stupid algorithm at the moment to pathfind, just looking around, and then as soon as it finds something, it just says, "Okay, I found the right path." But yeah, there are better algorithms that exist around. There are lots of them actually. We can implement more things. Something as well that could be cool is generating mazes. So you press a button, it puts walls everywhere, and it has only one path, and then your node will find the exit of the maze at some point. So yeah, just not to last forever, I will stop it here. But yeah, it was cool to present that. It was very interesting to build actually. And yeah, I'm looking forward to do more Rust in the future. Maybe not on the front end, but definitely Rust is cool. So any questions?
Are you going to use it for another project, Rust?
Yeah, so I used it. So I did something very stupid. I did the THA take-home assignment in Rust. So I redid it, and it's actually faster than Go, about 1.5 times faster. So with Go, I could get to 6 seconds to process the large file. With Rust, take about 4 seconds.
Nice.
Maybe
I like
another talk next time about that.
Okay, I like Rust a lot, but it's not mainstream, let's say.
Yeah.
So
It's not. And I don't think it's very good for web applications, because every time you get someone new on the project, they're going to be lost for 1 month. Like I've done this project and the THA, and I'm still I don't understand anything about Rust yet. It's very, I feel like the learning curve is very, very steep compared to Go, for example. So yeah, if you want to build something very performant, very fast, very secure, Rust is a good idea. Otherwise, for web applications and backend services, I guess Go is a better enterprise-friendly option.
Dimitri, what is the name of that company near our offices that uses Rust?
What? Near Amsterdam office?
Yeah, there is a Dutch company that uses Rust.
Doesn't want you to apply.
No.
Oh yeah, you're right. I think I heard of yeah, there was a startup or something. Yeah, it's quite an unusual choice. I think the amount of Rust jobs in the market is not that huge, unless you talk about some sort of more, let's say, low-level stuff, right?
Yeah. For example, Go doesn't do very well on embedding. I wonder how Rust does there.
Pretty good.
Nice.
Embedding as in embedded systems.
Yeah, embedded devices like tiny computers.
Yeah, I mean, I don't have any use case in mind, but I know it's used a lot, and lots of people are using it as a replacement for C and C++ because of the safety. There's no null in Rust, so yeah, you cannot have null pointer exceptions. It gets caught by the compiler, and that's a very huge difference compared to C and C++.